Hello everyone. Today we are going to see few important questions from the chapter triangles. These are 5 mark questions and they are really very important from the board point of view. So let's look at the first question which is not from the textbook. Okay. So the first question reads, in the figure we are given AB is parallel to PQ and it is parallel to CD. That means AB is parallel to PQ, PQ parallel to CD, all three are parallel to each other. We are given AB is X units, CD is Y units and PQ is Z units. Given this information, we have to prove that 1 upon X, we have to prove that 1 upon X plus 1 upon Y is equal to 1 upon Z. Is the question understood? Right? We also have information over here that AB is perpendicular to BD, PQ is perpendicular to BD, that's BD, and CD is also perpendicular to BD. Okay, this is the additional information that is being given in this question. Okay, and we want to prove this. So there's a very simple way of doing this question. We will look at the questions in two different forms. Like we'll look at the question as follows. We need X. Where is X? X is here. We need Y and we need Z. If you see carefully, AB is parallel to PQ. That means X and Z, if I compare, they will be over here. They are parts of these two triangles. If I'm understood by all, then we know that ABD is the triangle of which X is a part of it. And PQD is another triangle of which Z is a part. And both X and Y are part of PQ and AB, which is the base of the triangle. That means whenever we are dealing with the base of the triangle, we are not going to use BPT, we are going to use similarity. We know that, right? If we are talking about two triangles in this form, and say this is Z and this is X, these two, X and Z, they are base of the given triangle, say ABC and PQ. Whenever you are dealing with the base, children, you should always go with similarity, not BPT. Okay, so here we have made out that, okay, X is a part of triangle ABD, Z is a part of triangle PQD. There is a relation between X and Z. So let's find out the relation. If I look at these two triangles, we'll write here proof. We are talking about in triangle ABD or in triangle PQD and triangle ABD. Can we prove that these two triangles are similar? Only then we looked at the question and we were able to find make out that we need to use similarity. So obviously we are going to try to prove that these two triangles are similar. Which two triangles? PQD and triangle ABD. Now over here, can I say both the triangles angle D is a common angle to both? So can I say angle D is equal to angle D? Reason being common angle. Common angle to both the triangles. Now PQ is perpendicular to BD and AB is also perpendicular. So can I say that angle Q is equals to angle B? They are perpendicular, so each is 90. Each angle measures 90 and therefore we can say that triangle PQD is similar to triangle ABD and it is similar by AA test. Now because the two triangles are similar, we take the sides in proportion. While taking the sides in proportion, we get PQ upon AB is equals to QD upon BD is equals to PD upon AD. Reason being corresponding parts of similar triangles, corresponding sides of similar triangles or corresponding parts of similar triangles. Do we know PQ? Yes, PQ is Z. AB, AB is X. QD, we do not know. BD, we do not know. We have PD and AD. Do we need it? Mostly we won't need it. So for now, we'll just leave there. Now we look at the second set of triangles. Now what will be the second set of triangles? We are going to look at, say, this set of triangles now. We are looking at triangle PBQ and triangle CBD. We are looking at these two triangles now on the other side. So we'll write here in triangle PQB and triangle CDB. Same the way we wrote for the previous two triangles, that is PQD and ABD, we are going to prove here. What are we going to get? We are going to get this time which angle is common? This time angle B is common to both the triangles. So we'll write here angle B is equal to angle B, common angle. Angle Q is going to be equal to angle D now because each is 90. So what do we get? Triangle PQB is similar to triangle CDB by again AA test. See, reasons are the same. That's why I am not repeating it. Now, after we prove that the two triangles are similar, we'll take the sides in proportion. So we are going to get PQ upon CD is PQ upon CD is equals to BQ upon BD is equals to PB upon, very good, BC. Do we know PQ? Yes, PQ is given as Z. So we have Z upon, how much is CD? CD is Y. BQ is unknown. BD is unknown. Again, PB and BC are going to be the hypotenuse. So maybe we won't need it. So which are the two things that we are going to need? We are going to need Z upon X is equals to QD upon BD and Z upon Y is equals to BQ upon BD. I hope you have understood till here. Now, if you look at the question, we have 1 upon X plus 1 upon Y. So, 1 upon X is here, 1 upon Y is here. That means we're going to add them now in the third step. So, in the third step, let's write, consider, now I can't just bring X without Z. So, we'll have to bring it along with Z. So, Z upon X plus Z upon Y. What is Z upon X? Z upon X is QD upon BD. And Z upon Y is BQ upon BD. On your left hand side, if you see, we can remove Z common. We will be left with 1 upon X plus 1 upon Y. And over here, we have a common denominator BD and we get QD plus BQ. Right? We get QD plus BQ. Look into the figure. We have Z times 1 upon X plus 1 upon Y. Can you tell me what is QD plus QB? Very correct. It's BD. So in the numerator, we have BD upon BD. Why? Because B dash Q dash D. These 3 points are collinear. This is the reason why we are able to add it. And hence we get 1. 1 upon X plus 1 upon Y. The multiplication of Z will come down and become division. And hence we prove it. So we are going to make use of similarity. Prove the two triangles similar. And in third step, we add the relations and we get the TPT. I hope you have understood this question. If you have any doubts, please feel free to message on the videos. I'll try to incorporate your doubts as well as other questions in the next video. Hello everyone. Let's continue with the second video on triangles chapter. Let's look at an important 5-mark question from the board point of view. Okay. Let's read the question carefully. The question says, in triangle ABC, AD is the median. We have the triangle ABC over here. Triangle ABC is here. AD is its median. We know what is a median. A median is the line segment joining the midpoint of a side to the opposite vertex. That means D is the midpoint. D is the midpoint of which side? BC. So we have BD is equal to DC because AD is the median of triangle ABC. Then we are told that BO and OC on producing meet AC and AB respectively at E and F. Now AD is being extended to point X such that OD is equals to DX. We are supposed to prove that EF is parallel to BC. And then we are going to prove that AO upon AX is equals to AF upon AB. Right? I hope the question is understood. So if you look at the proof part of it, first of all, our attention should come to the data that is being given to us. If we highlight or if we focus on the quadrilateral. Which quadrilateral? OBCX. Sorry, BOCX, not OBCX. BOCX. If you look at the quadrilateral BOCX, we can say that in quadrilateral BOCX, we know that BD is equals to DC. Why? Because AD is the median, therefore it divides BC into two equal parts. Second, we know that OD is equals to DX. Why? This is given to us. So we can say both the diagonals. Which are the diagonals? Diagonals OX and BC are bisecting each other. Bisect each other. The diagonals bisect each other. And therefore, what we can say, because the diagonals are bisecting each other, we say that the quadrilateral BOCX is a parallelogram. It's a property of a parallelogram. Now, because it is a parallelogram, we can say that BO is parallel to CX and and BX is parallel to OC. Right? We get this as parallel, these two parallel, and then we have these two parallel. Using this information, we are going to try to prove that FE is parallel to BC. Right? Now, for the second part, we consider this as, we will consider which triangle? We are going to consider triangle. We know that OB is parallel to CX. Right? So, can we say that BE is parallel to CX? And instead of taking BE parallel to CX, we take only and only OE parallel to CX. I hope you are understanding. What did we write? We said BO is parallel to CX. This implies that BE is parallel to CX. And because BE is parallel, we can say that OE is parallel to CX. Why? Because parts of parallel lines are parallel. And then we say in triangle AXC, in triangle AXC, AXC, what do we have? We have OE parallel to CX. We have OE parallel to CX. Now we can apply BPT over here. OE is parallel to CX. Therefore, by basic proportionality theorem, we can write, take the sides in proportion. AO upon OX is equals to AE upon EC, isn't it? This is what BPT says. If a line is parallel, if one line is parallel to the parallel, one pair of opposite sides, sorry, I'm really very sorry. If OE is parallel to CX, then AO upon OX is equals to AE upon EC. Similarly, we know that, what do we know? We know that this time we are going to say OC is parallel to BX. Now, if OC is parallel to BX, we can say that FC is parallel to BX. And because FC is parallel, we can say FO is parallel to BX. And then we are going to consider this triangle. Which triangle? Can you name the triangle? Yes, ABX. What we did on this side, we're going to do on the other side of the triangle now. We'll write the same thing. We'll say OC is parallel to BX, means that FC is parallel to BX, and instead of FC, we can say OF is parallel to BX. So we get OF is parallel to BX, and then we will say in triangle, we'll write here, in triangle ABX, OF is parallel to BX. Therefore, by BPT, we are going to get what? This time we'll get AF upon FB is equals to AO upon OX. If we look at these two carefully, look at these two carefully. We have AO upon OX is equals to AE upon EC, and AO upon OX is AF upon FB. So can we say that AE upon EC is equals to AF upon FB? We get from here, no? AO upon OX, AO upon OX, right? So therefore these two ratios are equal and we got it. What did we get? We got AE upon EC is AF upon FB. AE and EC, AF and FB are part of triangle ABC. They are part of triangle ABC. So now can I write over here fifth part? In triangle ABC, since AE upon EC is equals to AF upon FB, by converse of BPT, what we shall get? We will say that EF is parallel to BC, right? This is converse of BPT, no? Right? So first part is done. So we finished the first part. Done. Now we want AO. AO and AX. And I think we've got it over here. AO upon OX we have, right? And if you remember the previous videos, we have used, we want a relation between, the question says we want a relation between AO, AF, this side. So that means we want a relation from here. So I'm going to consider this equation from here, sorry. We are going to write here, consider AO upon OX is equals to AF upon FB, right? You want that? Let me just erase the previous marking so that it becomes little clear for you. Okay. Now what did we get? We wrote AO upon OX is equals to AF upon FB. So what are we going to do now? We are going to add 1 on both sides. So we are going to get here AO upon OX is equals to AF upon FB. In my final answer, we need AO. We need AO, we need AF. So I'll invert it first. First, if we invert this, what are we going to get? Quickly tell me. We are going to get OX upon AO is equals to FB upon AF. We have just inverted it, right? We have just inverted it. And now we are going to add 1 on both sides. We've done this when we apply BPT. We know we can add 1 to both sides. And by doing so, I'm going to get OX plus AO upon AO is equals to FB plus AF upon AF. Now, if you look into the figure carefully, AO plus OX is AB, AX, OX plus AO is AX upon AO, and FB plus AF is AB, right? We got AO. And my final answer is again the inverted form. So by invertendo, I'm going to get AO upon AX, or reciprocating both sides. You can say whatever you wish. We'll get AO upon AX is equals to AF upon FB, right? Hence we get this one. Let me explain the next part, the other part again to you. We have considered this ratio because the question was AF upon AB, AO upon AX. So we considered AF upon FB, AO upon OX. We wanted AO and AF, so we inverted because whenever you add or subtract, the numerator changes. So whatever you want back should go in the denominator. So to do that, what did we do? We did invertendo. Invertendo is nothing but reciprocal of both sides. After reciprocating, what did we do? We added 1 to both sides. We got OX plus AO upon AO, FB plus AF upon AF. When we added OX and AO, we got AX upon AO. FB plus AF is AB upon AF. Final answer was in the reciprocal form, so we reciprocated again invertendo. And hence we get the answer. I hope you all have understood this question. It looks a little complicated, but it is not at all. We have to just, the key part of played over here is by understanding this part, the star part. The star part is proving that BOCX is a parallelogram. I hope this was helpful and you all have understood this question. Children, until and unless you pen it down, until and unless you write and practice, by watching videos alone, it will not help you. So put, right, copy the question as well as the solution and then do practice it. I hope this was helpful. Thank you.